I was asked if the brain atrophies from the outside in when it comes to dementia. With each different type of dementia, there comes a different way or a different location that the brain atrophies. So, to explain it further, I thought I would show you some brain MRIs and go over where the actual atrophy is occurring. So, the top left image is of someone experiencing Lewy body dementia. Lewy body dementia is one of the most heartbreaking and horrific types of dementia, in my opinion, and everything that I've read about it. The Lewy body proteins can build up anywhere in the brain and causing a variety of different symptoms to occur. In the top left, you'll see in the darkened area, that's where the atrophy is occurring. It should look white, except for in the middle, what looks like a little butterfly, that's the actual ventricles that are filled with cerebral spinal fluid in the brain. But the other areas that you see, this person is affected a little bit in the frontal lobe, quite a bit on both the left and right side of the temporal lobe, the parietal lobe, which is below the temporal, back into the occipital lobe, which is the back of the brain, and the area that is highlighted, it's showing that the hippocampus is still largely intact. And the hippocampus is what's responsible for splintering off short-term memories, converting them into long-term memories, and then splintering them off into different parts of the brain in case something was to happen in the different areas of the brain. Then there will be splinters of memory that person can hold on to. The image below it is an image of Alzheimer's dementia, and this person is affected in the frontal lobes as well as the temporal lobes, parietal lobes, occipital lobe, and the most devastating part is the hippocampus is nearly gone with this person. So that means that they will not be able to hold on to long-term memories, or actually have short-term memories converted into long-term memories and splintered off into part of the brain. So this person will really struggle with all different types of memory. The right upper image is of somebody with FTD. FTD dementia affects the frontal lobes and the temporal lobes mainly, and that's what you see in this image. The frontal lobes, which is the top portion of the image of the brain, is atrophied greatly. So this person will struggle with judgment, problem solving, learning, and their speech will be affected greatly. But they still have the hippocampus to help them with the long and short-term memories. The bottom right image is of somebody with vascular dementia, and vascular dementia can vary as well along with Lewy body dementia. It depends on where the small blood vessels are affected in the brain. When the small blood vessels are affected and die off, it takes the neurons with it, leading to the brain to atrophy in those locations. So you can see a variety of different presentations or pathologies on an MRI when it comes to vascular dementia. This person has some atrophy occurring in the frontal lobes, also in the temporal lobes and parietal lobes, a little bit on the occipital lobe. So that's how you'll see it present differently with MRIs. This is an image of my MRI, and you can see that the frontal lobes, which is the top portion, I'm experiencing atrophy. Also atrophy in the temporal lobes, the parietal lobe, mainly on the left and the right, and then also in the bottom is the occipital lobes, so some atrophy there. This was from 2018, so it has just continued to atrophy as time has gone on. But this gives you an idea of how my brain is different than the others, where my ventricles in the middle is filled with the cerebral spinal fluid. Let me show you a side view too to give you another perspective. So you'll see some atrophy occurring, like I said, in the frontal lobes, the temporal lobes, the parietal lobes, and the occipital lobes, on the outside as well as on the inside, because of the hydrocephalus that I was born with. I'm also missing some important anatomy of the inside of my brain, which is the corpus callosum, and I'll show you a different image to show you what I'm missing, but it's in that middle area of the brain. So let me show you what a normal 68-year-old male looks like and what their brain should look like. And again, keep in mind that I'm 54. So this is what a healthy 68-year-old male would look like, and all the brain mass that this person has. So while I was talking about my brain, in the middle, you'll see that what looks like an upside down C. It's white in the middle of the brain. And that was very hard to visualize on my MRI. And I am missing the back portion of it, a third of the back portion. And that means millions and millions of neurons are missing that pass messages from the left to the right hemisphere. And also, you'll notice that this person has quite a bit of brain mass in the middle of the brain, where mine is pushed up. And so over time, as this person goes through normal aging, they will experience very little or minimal cognitive decline as they age. With mine, because that brain mass is missing, I will experience more severe cognitive issues as time goes on. And for those of you that are wondering at what rate someone with dementia, what rate their brain atrophies, with Alzheimer's disease, for example, their brain atrophies at a percent of 2 to 3% per year. A normal person, their rate of atrophy is 5% per decade after the age of 40. I'm not atrophying at the rate of somebody with Alzheimer's, but I am atrophying between 1 and 2% per year. So that's why the neuropsychologist can tell me that I don't have another decade to be living with my disease. I hope this was informative. If you have any questions, please comment below, and I'll get back to you as soon as I can. Have a great day.